Hi everybody, I would like to test something today that grasps my interest right now, and that is we are all able to exchange TCP messages via Netcat, for example, or any other TCP utility via the network between different machines, different terminals, from one host to another. And I would like to be able to encrypt those messages with my own little tool, my own little utility that I code in C today, that we code in C today. So basically we create our own little encrypted message exchange, something like maybe like a chat. So let's try and start with the most important part, the encryption. And for that, we will create our own projects directory and let's call it chat encrypt. And let's cd into that chat encrypt. And let's create a file encrypt.c. And then inside that file, let's include standard IO, and let's create a main method. And we don't need any arguments because we're reading stuff from standard in. So let's loop over the input characters. First of all, we have a character that is an integer. In this case, it's just an integer because characters cannot be negative, but in case the reading of characters from standard in fails, there will be a negative error code. So this is just allowing the data to have a bigger space of values such that when an error occurs, the error can be encoded as value -1. Yeah, but there won't be an error. We will just be reading characters from standard in. We can use the function getC for that. getC, and it reads a character from a file stream, or getCharacter, which reads a character from standard in. So let me just show you the documentation. And here it says getCharacter is equivalent to getC standard in. Maybe to make it more explicit, let's just say, let's use getC with standard in to make it clear to everybody that we are reading from standard in. And then, while the character C is not the end of file, wait, I messed up the parentheses, I think. Oh, that should be it. Oh no. The font was confusing me. I think this should be fine. Yeah, I was totally confused by this character here. And this is, by the way, because the font I'm using is combining the exclamation mark and the equal sign into this inequality sign. I don't know if I like it. I'm not really sure. The font I'm using is Cascadia Code. If I used Cascadia Mono, I think it wouldn't happen. So those are two variants of the same font, and one is doing this and the other is not. But I mean, it looks nice. It's just hiding some characters, which I think for programming is not always ideal. But I'll keep it for this video. Oops, what did I do? Okay, so we are reading characters from standard in until the end of file. The end of the file stream is reached, and then we are putting those characters to standard out. there must be a function put C, probably, put C. And there it is. So we are putting a character back to an output file stream. Standard out. Now you might be wondering, what is this doing? This is just reading stuff from standard in and putting it to standard out. So basically it's like a unity operator. It's not doing anything, like a unity matrix, if you remember that from linear algebra. All right, but we are not putting the character C to standard out unmodified. We are going to modify it by encrypting it or obfuscating it. But before we do that, let's go to the bottom right pane below my webcam, and let's check the chat encryption directory and see if the file, the code that we just created, compiles. And I'll just use cc, create an output file, enc, and then the input file is enc.c, and it compiles. We can also use gcc and it should make a difference, yes. And we can use the WALL flags and the -g flag in case we need to debug it. And the WALL enables all warnings. So this gives us more details about uncommon or unrecommended code practice that we are doing. Okay, but it seems to be working fine. Let's try to, now that we have a compiled binary here, let's try to use it. So we can pipe a message into this binary, and we expect it to output that same message to standard out, because that's what this code is doing. It's not working because I haven't referenced the binary properly. So now it should be working. And as you can see, yes, we are echoing hello world, piping the output into the encryptor, and the encryptor is outputting hello. I'm not echoing hello world, I'm echoing hello. And the encryptor is outputting hello unmodified. So we can go back to the encryption routine and let's do the following. Let's create a method that creates an encrypted character. Enc. So that's the encrypted character. And it takes as input the character C. And now we can create that encrypt method that takes as input the character C and returns the character C encrypted. For example, C, the character C, and we XOR it with the number 17. So for anybody not familiar with what's happening here, we are doing a simple XOR. Some character is placed in memory. Let's just say it consists of ones and zeros, something like this, and this is the character C. And then we are XORing it using this roof character with the number 17, and number 17 is also some binary value. What is it? I think it's 0. Wait, starting from the last digits. This. Wait, 1, 2, 4, 8, 16. This should be a 1 probably, and I think this is 17. I don't know. And then this is XORed, so only if exclusively one of the two bits is 1 and the other is 0, then we output a 1. I think this is the XORed version. I don't know. Maybe I made a mistake. Well, but we're performing an XOR, and the good thing about the XOR is that it's reversible. So if we XOR it with 17 again, then we get the original input again. And we get a warning, as you can see in this bottom right pane, about an unused variable, which is a good thing. That means I'm not putting the encrypted character to standard out, which I was forgetting. So here this warning was very, very useful. And now let's try to see. Let's go to the projects directory, chat encrypt, and yeah, let's try to see if we encrypt the input string hello. And as you can see, if we echo that into the encryptor, then this is the output. So it seems to be encrypted. It's encrypted with the key 17, which is currently hard-coded. This is the key. All right, and I would expect if we call the encryptor twice, then that would reverse the encryption. Because we encrypt with the 17, it's the XOR operation with 17, and then repeating the same XOR just reverses what has already happened. And as you can see, if we echo hello into encrypt and then pipe that into encrypt again, we get hello as a response. And that's effectively what we're going to do. We're going to send a message hello to the encryptor, then we're sending that via TCP to a different machine, and then that other machine is going to use the encryptor as well and decode the message. And that's how it works. Now, what we could do is we could provide an argument to the main method that asks for a key, for a password. Yeah, let's do that. Let's allow an argument to be passed. So we're passing the argument count here and then a string array argv, argument values, I think. And then we can check if the argument count is not equal to 2, then we print to console. And for that, we can include standard. No, standard IO is fine. We need just to printf. Printf with instructions, usage is enc, and then key. Something like this. So if the user passes in if the user doesn't pass the password, the key in, then he gets instructions on how to use the binary. And then we exit with an error code of -1. And maybe the exit function is defined in standard lib, which we need to include first. Yes. And by the way, for everybody not aware, the argument count is 2 because the first argument is always the name of the binary that is being executed. So we have two arguments, the name of the program and the and the argument. All right. So we are encrypting it. We are encrypting our character with some string that is passed. Now, ideally, we should use a hash of that string that then acts as a password. For that, let me just open a browser because I need to look up how to, well, what a good hash would be to use in C. We could technically create our own little hash, but that would explode the scope of this video. So C hash string. Yeah, DJB2. We have already we have in the past implemented that one ourselves. It's a very simple hash. We can use it. And we can even just copy this method and yeah. But I don't know. Yeah. All right. Let's use the DJB2 hash. It's completely fine for our video. So let me just copy that code for the hashing. So this is our hash function. And it's taking a string and then according to some arbitrarily defined number. This is just arbitrary stuff that someone has decided at some point. This is just an arbitrary constant. We could use any other constant, but this was found to provide or to produce a good hash space, a good value space of the hashes. The hash values are distributed well. Yeah. So this has just been experimentally determined. And then we loop over the individual characters of the string and then compute the hash according to this rule here. So there's no magic. If you want to know more about this hash, I have a video where we code this hash ourselves. Just look up DJB2 on my channel. DJB2. Yeah. Okay. Now, what we need to do is we can now, well, this produces an unsigned long. We technically only need an integer, but I think it's completely fine to now say we want to encrypt this integer C using a character or a constant character pointer using a key. And then we XOR the character using the hash of that key. And that returns an unsigned long as far as I know. Maybe we can do int hashed key maybe, or key hash is more precise. Pass as input the key to the function, and then we XOR the character C with the key hash. Let me just change that to constant character pointer. I don't know if that method prototype is really making much sense, or if that unsigned is if that's really required because all characters are unsigned as far as I know. Unsigned long, that's fine. Yeah, I think it's fine now. And we get a warning in the hash function, I think. Suggest parentheses around assignment used as truth value. Yeah, that's just a suggestion around the assignment. It's not strictly necessary. And because I'm just reusing that code, I don't want to modify it and break it accidentally, at least not in scope of this video. So let's just keep it as is. And in the encrypt function, we are going to pass our key. Let's call it input key, and that is the first entry in argv. Not the zeroth. The zeroth is the name of the executable. Okay. And I think that's it. We have this one warning here. Yeah. Let's keep it as is. So now we should be able to call the encryption function, let's say with the word hello. And now if we execute it like that, we will get a usage message printed out because we haven't provided a key. So it asks us to provide a key as input for encryption. So let's say I want to use the encryption key bulldozer, and that encrypts the input string with this. So this input key right here is hashed, and then the hash of that key is used for encryption. And now we can do Now we can output or input the output from that into another encryption invocation, bulldozer, and then let's pipe that into bulldozer again for decrypting the message again, and we get the original string back. So that's already quite nice. And I think that means that our encryption tool is working. And now comes the fun part. Now comes the part where we try to transmit a message over the network. Let's create a new pane for that. And it's going to work like that. Let's go to the projects directory, chat encrypt, that we just created. And by the way, we can even create arbitrarily large files. Let's call our file file.txt. This is my message, and it can be arbitrarily large, and we can just pipe that file into the encryption routine, provide some password, bulldozer, and it outputs that entire file to standard out. And we can also, of course, output that into another file using this operator here, the redirection operator. Let's call Let's call it file encrypted text. And as you can see now, we have an encrypted text file that contains the encrypted text. Super nice. And now we should be able to pass the encrypted text into the encryption tool again and decrypt it. And as you can see, we pipe the encrypted text into our encryption tool and decrypt it like that. Super nice. So it works. I'm actually quite proud of that. I just love when things just work without too much headache. And this is quite nice. I mean, it's very, very simple and so powerful. It's really powerful. The limitation of that encryption tool is that it's encrypting with a key hash, and that is an integer, and that integer has a size of, I think, 16 bits. Yeah, so you could increase the complexity or the security of that by increasing the size of the key that is used to encrypt. In our case, it's just 16 bits, so very simple, but completely sufficient for our purposes. Not 16 bits. No, it is 16 bits. I was just confusing bytes and bits in my head. All right, let's clear this window and try the networking part. So for networking, we can use Netcat. And let's say the bottom terminal is the so-called server. The server is just a machine waiting for incoming messages. And we can use Netcat for that. So let's have a look. And Netcat is a tool that sets up arbitrary TCP and UDP connections and listens. So whenever you want to transfer stuff via TCP or UDP, or you want to play around with networking, you will have to do with Netcat at some point. I have to do it with Netcat at work currently, and it's awesome for testing. We are I am testing a tool that sends data to satellites, and I'm using Netcat to mock a satellite. I just set up a listener using Netcat, and it prints out everything that it has received. And yeah, using that approach, I can be sure that the TCP connection is working. All right, so let's create a Netcat listener. It's netcat-l, and that listener listens on. Or technically, we can listen for all incoming connections, which is the proper way to do it if you want to accept connections from anywhere, or you can just listen to connections on localhost. In this example, it doesn't make a difference because both programs are running on the same machine. But if you really want to listen for everything, then you can listen for all incoming connections from anywhere. And then you specify the port that you want to listen on. Let's say 7777. And now it's listening. Yeah, so if this wasn't listening, for example, if you defined a port that was too large, I would expect this to throw an error message. No, it's okay. It seems to be listening for anything. Maybe the sending part is just the problem. I mean, it can set up a listener on that port, but this port will never exist because the maximum port range is between 0 and 65,535 or something. Okay, let's clear this and set up a proper listener again. So this is now listening for TCP packets on this connection from anywhere. This is just a standardized way to say I accept connections from anywhere. You could also specify a definite machine name here. Okay, but now our instance is listening for messages from anywhere. And now we can create a Netcat instance up here and connect to localhost, because this is running on localhost. And let's connect to a port that doesn't exist for a first test and see what happens. It seems that my Netcat instance somehow behaves differently than the others I have worked with. Okay, but as you can see, in my example, nothing happened. We have to connect to the correct port, obviously. So let's netcat localhost 7777. And now this Netcat instance is forwarding anything that is input to it via standard input to localhost, this port, which is going to be sent to this thing right here. So let's send a hello. And as you can see, the hello that I input up here appeared also down here, because this is the client and it sent a message to this server. This is the client sending a message to the server. And as you can see, the message is being received down here, which is already super nice. So you have the server waiting for messages and you have the client sending messages. Of course, one detail is that in TCP, the difference between client and server is just who initiates the conversation. The client the server is always waiting for an incoming conversation to be initiated, and the client is initiating the conversation. But after that, it's not just the client sending messages, it's also the server who can send messages to the client. So once the connection is established, there's no difference between client and server. The difference between client and server is just who sets up the connection first. Yeah, so I can also send a message from the server and it will appear up here in the client. All right. And what I would like to try now, what I haven't tried before, is I want to pipe the outputs from this into the encryption routine and see if we can send encrypted stuff. So, and as you can now see, because I have interrupted this connection using Control-C, the connection was also terminated down here. So the program just exited. All right, so let's try the following. We can echo some message into Netcat localhost 777. And then we can also listen for that incoming connection down here again. And if we echo the message via standard in, and we pipe that message via standard in into the localhost client, let's see if that is forwarded to the server. And yes, it is. This means the piping into Netcat works, and we can also pipe an encrypted message. So let's set up the server again down here. So it's waiting for an incoming message again. And let's encrypt my private message. We pipe that into the encryption tool. We encrypt it using the keyword elephant. And then we pipe that. Well, that would no. Why doesn't it output anything? We echo my private message. Then we pipe that into the encryption routine and provide a key. I don't know why it is not outputting anything to standard out. Wait, have I messed up something? I'm echoing my private message into the encryption program, and then if I don't provide a key, it prints out the usage thing. If I do provide a key, it outputs something. Somehow the key elephant is not okay. Elephant. Maybe the message that is resulting after being encrypted is not part of the ASCII character space and therefore cannot be printed to the console. We can check this by piping the result into encrypted.txt, and let's have a look at that. Yeah, so we have some weird characters here. They are probably not supported by the console, but the encryption works. Okay, so that is confirmed. And now we can echo my private message into the encryption tool, provide a key, elephant, and then we can send that using Netcat localhost 777 as the client. We can send that to the server down here, and let's see what happens. It doesn't print anything because it doesn't print the characters, the magic characters, to the console, as we already learned. But I think a message should have been received here. This example is just a bit flawed because the encrypted characters are not visible. What we could do is we could set up this, and what it does is it pipes stuff into encrypted.txt. And let's see. And let's see if the file exists. And yes, okay, so the data was transferred. This file didn't exist here before because this is the home directory and this is a different directory. So this encrypted.txt file is not the same as this one. Okay, so the data transfer works. Now what we can do is we can send a private message, have it encrypted here, and then now I need to go into the chat encrypt directory here as well, open a Netcat connection as a listener, as a server, and then pipe the result into the encryptor with the same password, elephant, and listen for it. So now let's send the private message, encrypt it, send it via TCP connection via Netcat to this port. Then that message is received here and decrypted again. So I would expect now the message to be sent here and be printed here and to be printed here in clear text. Let's see. And as you can see, we have sent the message, encrypted. We have sent the message in an encrypted way, and it has arrived here, encrypted, and was decrypted right away from the encryption tool. And that, everybody, is how you can encrypt network traffic at the most basic level. You just send messages to some encryption tool and then use some TCP utility or whatever networking utility you want to transfer it to a different machine. And then on that different machine, you can decrypt that stuff, the messages. For example, if I send that same message and at the receiving end or at some man-in-the-middle attack, at some intercepting end, the password that was used is not known. For example, unknown password, because the attacker doesn't know what password you used up here. Well then, let's listen here for the incoming message and let's send it here. And as you can see, we have sent a message in an encrypted way and the receiver was not able to decrypt it. Only if the correct password is used, which is elephant. Let's send the message. Only in that case will the message be decrypted properly. Well, and that is how encryption over the network works at the most basic level, how you can make it work for your own projects. Of course, there's an endless amount of security improvements that is possible there. There are protocols you can use. There are better hashing algorithms that you can use. There's so much stuff, but I like to stick to the basics. Those are the basics, and using those basics, you can send encrypted stuff over the network. Awesome. If you enjoyed this, then stick around and see you next time. Bye.